Hey everybody, welcome to another math video. For this one, I will be showing you how to derive the Pythagorean theorem. Alright, so that's what we'll be doing, like I said. Okay, so at one point or another, you've probably seen this video. I'm sorry, not video. You've probably seen this formula, a squared plus b squared equals c squared. You've probably heard it something like the sum of two sides of a triangle is equal to the square of its hypotenuse, or something like that. And it's confusing because without a picture, it's kind of hard to visualize, but I'll be showing you guys how to derive this. There's a couple of different ways. I'll be showing you the way that I like, most comfortable with showing, and personally, I think it's the easiest method, so let me show you. Okay, so what we'll start with is a square, and inside of this square, what we'll do is we'll inscribe another square, but not exactly, we'll inscribe another square in this big square that where the four corners will be touching somewhere along the side of the outer square, not exactly in the middle, so something like this. Okay, so with these being squares, we can automatically assume a couple of things. One is that we have right angles. So we can automatically assume that these are right angles because we know that this is a square. Same goes for this square. These are right angles. Okay, so now since this side, we'll look at this side. Since this side here is being intercepted by this corner from the inner square, we know that this side here is being cut into two pieces, but we don't know the length exactly, so we can label them like this. And since the outer square is being intersected at the same points every time, we can also label the other sides the same. So this side corresponds to this side, corresponds to this side, corresponds to this side. It's not going to be this side corresponds to this side, corresponds to this side, because it's all uniform. Okay, then we also got to do the notations. So since we know that this is side A, and this is side A, and because this is a square, we know that these sides are all going to be the same measure. Same goes for side B. We know those are going to be all the same measures also. Now if we look at the inner square, we're going to label each side C, and because of course it's a square, we know each of the sides are the same measure. Okay, so we use these hash marks. The number of the hash marks tells you which one goes with which one, so if I didn't have the labels A, B, and C, you could still tell which sides are corresponding, or the same measures, just by the number of hash marks that they have. Okay, so now, next thing we're going to do is we're going to look at area formulas. Okay, so if we look at the outer square, we see that one side here is a combination of A and B. So if we add these two sides together, we get A plus B, and we know that the area formula for a square is one side squared, or one side to the second power. So the area of the outer square is going to be A plus B to the second power, or A plus B squared. Okay, and it's important that you use the parentheses there, because if you don't use the parentheses, it looks like you're just doing A plus B squared, where it's only the B getting squared and not A and B getting squared together. Okay, now we look at the inside, we look at this square right here. So one side of the square is simply C. That's going to be simpler. So the area of the inner square is going to be C squared, or C to the second power. Okay. Now there's one more shape that's in here, and that's a triangle. Okay, so the area formula for a triangle is 1/2 times the base times the height. So the base and the height are going to be around the right angle, So if you look at this triangle here in the upper right, here's your right angle here. So we'll say this is the base and this is the height. Or similarly, you could say this is the base and this is the height. It doesn't really matter. Okay, so it's going to be 1/2 times the base times the height. And it doesn't really matter which one is which because we're going to use both anyway. So 1/2 times A times B. Pretty simple, right? Okay, so now that we got everything all set up, let's start working out the formula. Okay, so before we could even have gotten started, it's important that we define all of these things first, because we need to make sure that our squares are squares. Okay, so what we'll do is we'll start building our equation here. So if we take our outer square, the a plus b squared, the area of the outer square, we can make it equal to the stuff that's inside. Now notice I said stuff and not square, because of course these are two different size squares, so their areas are not going to be the same. Okay, and that's apparent because of the hash marks here. Right. So if we take the area of the outer square, like I mentioned, a plus b squared, we'll make it equal to the stuff inside of the outer square. So inside we've got this smaller square, which we know from the previous slide, the area is c squared, and we'll add in all these triangles too. So we should start off with something that looks like this. So we got the outer square's area here. This is the inner square, the area for the inner square, and this is the area for the triangle. But we got 4 triangles, right? One in each corner. So that's what this 4. That's where this 4 comes in here. Okay, so now just to kind of help you guys visualize this, I'm gonna expand this a little bit. So I'm gonna get rid of this exponent here by expanding the a plus b squared to look like this. Okay, so remember, exponents mean repeated multiplication. So because this is a 2, we're going to need 2 of these. So a plus b times a plus b. Alright, so the next step, what I'm going to do is I'm going to FOIL and simplify. Okay, so on the left side of the equal sign, I'm going to FOIL. And if you need a refresher on foiling, you can check out my other video on foiling. That should be up soon. Alright, so with the left side foiling done, we get something that looks like this. And on the right side here, I'm going to simplify this. So 4 times 1/2 is 2, because 1/2 of 4 is 2. So that's where this 2 came from. Okay, now on this side, I got an AB here and an AB here, which makes them like terms. And if you're still iffy on like terms, check out my other video on like terms. That should also be coming up soon. And since they're like terms, I can combine them. So this will simplify to look something like this. Okay, I got 2 ABs here. Now I'm going to subtract 2AB from one side. Okay, and if I do that, I gotta do that also on the opposite side of the equal sign. So if I subtract 2AB here to keep it equal, I also have to subtract the same thing from the opposite side of the equal sign to keep it balanced. Okay, it's the golden rule of algebra. Balance. Okay, so once we simplify, we get a squared plus b squared equals c squared, which is our Pythagorean theorem. Alright, so to sum it all up, we derived the Pythagorean theorem. We used the area formulas, specifically the area formula for a square and the area formula for a triangle. Once we had those, we put them into an equation and used algebra to get down to our Pythagorean theorem. Well guys, I hope you found this video useful. I can see this coming up as some kind of extra credit on one of your tests or homework assignments. But yeah, well, thanks for tuning in, and I will see you next one. And see you next time.